this, why not? Okay, so for today's lecture, we'll be reviewing the code for three sorts: bubble, insertion, and selection sort. This should help you with your sorting worksheet number 2 due this Friday. So as a visual reminder, we start with the simplest kind of sort. Here is bubble sort. Notice how the swapping that occurs, how the largest number bubbles upwards. Okay. And so all these, or the three types of sort we'll talk about, are big O of n squared. They all use nested loops. So in bubble sort, you see the standard nested loop. You have an inner loop and an outer loop. Okay. And the fancy stuff is what happens inside the inner loop, and that's the swapping code. Once you find a bigger number, you need to change positions. So as we dive into the code, this is the stuff that is important. Notice this is the code for swapping. It's 3 lines. To swap 2 variables, you need the help of a third variable to help you store that value. And the key parts with bubble sort is that the swapping code is inside the inner loop, as you could swap, or you should be swapping, like many times, right? That's one of the features of bubble sort. Nothing too fancy, if statement, 3 lines for swapping. Now we can improve it, because as you get to the tail end of bubble sort, you kind of have that idea of like a sorted and unsorted bits of your array. The right hand side, the top end of your list, will always be sorted. So you don't have to check through and make like unnecessary swaps, right? Because you know it's already in sorted order. No swaps will occur. So by taking away where you're at, the outer from the limit, the stopping point of your inner loop, you save a couple comparisons. You can continue this idea further by saving some swapping. If it already happens to be in the correct order, then you don't need to do said comparisons. And you can make use of this flag, no swaps. If it so happens that things are already in order, then you don't have to go through this redundant checking. In which case, like at the final pass, if everything's already sorted, then we're done, we're stopping. So tiny ways to make bubble sort more efficient. If you like this kind of thing on how to make these algorithms better, then an algorithms course is definitely for you. You may enjoy computer science theory, as this is what it discusses. I really enjoy it. Right. So bubble sort, although not often tested on the AP test, is a good starting point. It directly relates to this next sort that we talk about, selection sort. Here is a visual reminder of what happens in selection sort. This idea of swapping still occurs, but now you are remembering indices of the smallest number. And the swap occurs in a little bit different spot. Notice that you check and compare through everything, make one swap. Selection sort for sure does less swapping compared to bubble sort. There it goes, speeding up, looking for the smallest number, moving it into the right position via a swap. And you have that idea of a flag that remembers the index of where you're swapping and the index of the next smallest number. Okay, there it goes, ta-da. So let's take a look at the code. Stare at it for a while. We see int, temp, we see our for loop. We see that familiar swapping code as in with bubble sort. But notice the sequencing is a little different. So one of the key features with selection sort is that the swapping occurs after the inner loop. The inner loop's job is to find the position of the smallest number. Once you found it, once this loop is done running, then you swap. and repeats. Other key features of selection sort is that usage of a flag that stores the index of the smallest number. Very common mistake when coding it up on your own is to mix up the index, here we call it flag, and the element at that index, list square bracket flag. Again, we go back to the analogy from the first semester. This is like confusing the apartment number with the person who lives at that apartment. Lastly, we have our insertion sort. We'll let this animation run a little bit to remind you of how insertion sort works. Keywords from before the break are sliding things over. You're comparing the elements, not the indices. Okay, let the animation go again. Will you play? No. Okay, and other keywords to help you remember insertion sort. This is where you have that sorted and unsorted portions of the array. Notice what's currently in yellow will be sorted, and what's in blue is unsorted. You insert these numbers into the correct position by sliding numbers over. And it's this idea of slide that makes the insertion sort special. And that's one of the key features. Notice instead of having an inner loop being a for loop, it has an inner loop being a while loop, as this is what it means to slide something over. Okay, so while you are somewhere in your array, you take a look and compare, is the position you are, key is the number you're currently looking at. This is the one number to the left. If the number to your left is bigger than you, then you must move it over one to the right. And keep doing so until you are smaller than the number to your left, in which case you have found where you belong. So that was my attempt at translating this code into plain English. You may want to stare at it and make sense of it yourself. You know it means slide, but maybe walk through a couple of those examples in a unsorted list and walk through and see that, this is sliding stuff over. Notice that key is storing the actual elements. It's not doing the index stuff like selection sort is. Right. So those are the three kinds of sorts. You should be able to practice now working on the sorting worksheet number 2 that's due this Friday. Again, from the AP exam, you aren't expected to write this code from scratch, but you are expected to recognize this code. We will talk about merge sort in the coming days. And if you want to practice, you can think about, okay, how do you swap two elements, and then how do you merge two arrays together? Those are two subproblems that are needed in merge sort. And so you can preview these things. This slide, it seems like Mr. Simon added sometime this morning. So if you want to do something over the summer, it seems like you can sign up for CS 111C at City College and get college credit for this. By taking Computer Science A, you've done the equivalent course, which is this CS 111B. So for like a student asked me previously, like, oh, what was there anything to take at Lowell to after APCSA? Kind of. You could take computer programming B, and you can learn Python, but otherwise this is the end of your computer science journey at Lowell if you don't choose to explore it at various clubs. If you want a link, I'm unsure about how the City College enrollment works, right? But how I would do is like look up this You want a course catalog. You probably need an account of some sort with City College, summer 2021. Look up this thing, and you'll have to go through that enrollment procedure. I think they use something like SysWeb or something like that. No, City College of San Mateo has that thing. So then read through this stuff, right? Oh, there's a prerequisite form too. Cool. In which case, what? When you, I don't know whether they will take like unofficial transcripts for high school, whether like you got an A for this course as like satisfying that prerequisite, or do they have to take AP exam credit? I'm unsure, but if I need to sign something, I will, and you need to talk with your counselor. So, yeah, as for links, like go here, browse through the City College website. You all are good at perusing through information. Okay, if anyone here has more information on that, you can type in the chat or reach out to each other for help. I think some of you may have already taken college courses at City College before and could advise your peers. I think it's like pretty easy, and like from what I remember, the City College computer science courses really aren't too bad, especially if you take it with a friend here that you know. You could take the course together and like breeze through it. Often college courses allow you to have partners and things, and if you choose a very competent partner, then you'll have no problem. All right, so that's it for today. We talk about merge sort next, and we may start review later in the week. We'll see. You can treat the remaining minutes for class time as open office hours, but formally, you're all dismissed. Have a good one.